Okay, all right. So Isaac, what'd you get for sine of theta?
Opposite over hypotenuse.
Right, but you look over here.
Oh, 6/10.
Yeah, okay, so this side is called the opposite.
Yeah. That's hypotenuse.
This is called the what side?
Adjacent.
Adjacent. And
Hypotenuse.
hypotenuse. Okay, so you said it's what over what?
6/10.
He says 6/10. Reduce your answers, please. What is it? 3/5. Okay. Everybody agree? Okay, cosine of theta. Hannah, do you know it? Okay, Hannah, you okay with this? Yeah. Okay, remember cosine is just going to be, if you look up top, SOHCAHTOA, it's going to be adjacent over what? Hypotenuse. So you're going to say 8/10, I hope, which is 4/5, right? Okay. Tangent of theta, Elsa?
Opposite over adjacent.
Opposite over adjacent. Okay. Which means take your numbers, what? Opposite
6 over 8.
over adjacent. 6/8, which makes
3/4.
3/4. Correct? Okay. That's it. That's what you're doing today. A lot of that, okay? Okay, now, you know, if I just asked you, I hope this is simple. This comparison, 3 to 5, means something. It means the opposite side is what? 3, not 3 times bigger, 3/5 of the what? Hypotenuse. Now, this would be easier if you said it this way. 3 out of 5 is 60%. 60%. The opposite side is 60% of the hypotenuse, which means it's shorter, right? Okay, it's a little over half. All right, that's what ratios tell us, okay? Now, if I go here, I just need to tell you something about this. This is more next week than it is today. So do this for me, please. We're gonna talk about circles in trigonometry a lot. So I made a circle. We call it the unit circle, and I made it around the x-axis and the y-axis. And what we do is this. We basically say, let's draw a triangle in quadrant 1, 2, 3, 4. Okay, if you were to draw a triangle in quadrant 1, you go like this. If I told you somewhere on this circle, go to this point right here, call it this. Call it X, call it Y. Okay, if I told you to make a triangle in that quadrant, here's how you do it. You jump on that point, and you go straight down to the x-axis, back to the origin, and back to the point. So how did I do that? Pick a point, go where?
Straight down.
Or go to the x-axis, then where?
To the wall.
Origin, then where?
Back up.
Okay, so there's your triangle in the first quadrant, and this is the right angle, and this is where theta hides every time. Hides right there, right by the origin. Now this is what we call a standard angle. Okay, a standard angle. Now, what if the point x comma y is over here? Oh, I forgot something. Sorry. I need to label the legs and the hypotenuse. What are the legs going to be?
On the one on the x-axis.
How far is this right here?
7.
Nope.
X.
Adjacent.
It says right here it's what?
X.
I went from there to there. That's x. And then I turned the corner and I went up.
Y.
That's y. Now here's the hard one. What's the hypotenuse length?
X plus Y.
No. This is a circle.
X squared.
This is just a circle. Here's the origin.
Radius.
It's the radius of the circle, so it's r. Now, here's why I have to introduce this to you, because you know how I say sine is opposite over hypotenuse? Now they go into x's and y's and r's. They say, what would sine be here now? Opposite
Y.
over hypotenuse, r. So if you guys go back here and you just write those two words, sine is just opposite over hypotenuse, but in our case it will be what over what? Y over R. Does that make sense? Instead of using the words opposite hypotenuse, they use y over r. Now, cosecant is the reciprocal function. That would just be hypotenuse over what? Opposite. So really just do what to these two letters?
R over Y.
R over y. Okay? Now let's think about cosine. Cosine is just adjacent over what?
Oh, hypotenuse.
Okay, so then now look at your x, y, r's over there.
X over R.
X over r. Okay, I hope this is getting easier. The reciprocal function secant would be what over what?
R over X.
R over x. Yeah, I'm not going to write that out, Carlos. I'm just going to start writing these letters in now. What about tangent? Opposite over
X
adjacent.
over Y.
X over y. Do you agree with him?
Actually, Y over X. Y over X.
Yeah, it's y over x. Okay, there you go. So tangent is just y over x, where cotangent would be the reciprocal of this, x over y. Okay. You know what? This is all up above. Remember when I crossed it out? Yeah, it was right there for you. I just didn't want you to look at it right away. But it's all right here and here. So it was there in the beginning anyways. It's either sine is either y over r or it's opposite over hypotenuse. That's all. There's two ways to say it. Good?
So the trigonomic ratios for a circle and for a right triangle are the same.
Yes, they are. One of them uses words and one of them uses x, y, and r. Okay? Now, the thing I want you to kind of know is this though. Whoa, look at that. I erased it. I want you to know standard, actually it's standard form of an angle is going to be found in these four quadrants. You know what? I wasn't quite done. How do you draw a triangle in this quadrant? Remember how I picked a point here?
Yeah.
Well, let's pick a point here. How do I do this? Go straight to the x-axis. Now where?
The origin.
Origin, now where?
Back up.
Back to the point. This would be theta. This would be your right angle, right triangle. So if you pick a point in the third quadrant, go to x, go to the origin, go back to the point. There's your right triangle. There's theta in the corner again. It is amazing how many students can't draw these triangles. But this is the proper way to draw them. If you pick a point in the fourth quadrant, hit the circle. Go where? X-axis, right angle. Back to the origin. There it is. And then where's theta? Right in this little area right here.
Theta.
Theta. There you go. Okay. Now you'll see why I just did that on this problem right here. Here comes problem one. Problem one says, take that point, find the values of the 6 trig functions for the angle in standard position. Standard position is what I just showed you. So, tell me this. Where is that point? Negative 6, 8.
Negative
Left
6.
6.
Okay.
Up 8. So there's 8, and there's negative 6. There's the point right here. Okay? It says find the values of the 6 trig functions. You can't do it unless you have a triangle. I don't see a triangle. Do you?
Oh, you have to make it.
You gotta make it. So how do we make a triangle in the second quadrant?
Go down.
Straight to the x-axis.
Over.
Over to the origin. Back where?
To your dot.
To the point. There it is. Right angle there. Okay. Label your legs. What are your legs?
R. X and Y. No,
Well-
negative 6 and 8.
Yes, negative 6 for this leg. Positive 8 for this leg. Correct?
Yes, sir.
Okay. This, I don't need this anymore.
Yes, sir.
Okay. Right angle. Okay. What am I missing? Hypotenuse. Okay. How do you get hypotenuse if you know leg? Look at, what's that called?
Negative 6.
Pythagorean theorem.
Okay, Pythagorean theorem. Let's do it. Ready? 8 squared.
Squared, 6, negative
Let's-
6 squared.
The other leg squared equals hypotenuse squared. 8 times 8, 64.
64.
Negative 6 times negative 6.
36.
Add the two together. Take the square root of both sides. Get what?
And
Hypotenuse is what?
Radius is
10. The radius is 10. You're right, Jay. So if you think about a circle, guys, look at this. There's that circle, right? The radius is 10. Okay, fill it in now. Get all 6. Yes, you can. Come on in. 30 seconds, get them done. Just go way in the back corner by the flag.
I telling you.
What's this-
How's it go with my marketing class?
Sign. Sign and date. Victoria, since you're giggling, just give me sign and date.
You're so stupid.
8 over 10. Hey guys, you know what I didn't do?
huh.
I never put theta in the right spot. Where is theta? Right by the origin. It's the angle right by the origin. So is she right when she says 8
Yes.
opposite over hypotenuse? Yeah, 8/10.
4/5.
4/5. Okay.
5/4.
Cosecant, the reciprocal function is
5/4.
5/4.
Where
Okay.
did the 10 come from?
Well,
Hypotenuse.
hypotenuse. I did the work right there. I did the Pythagorean theorem.
Come to this class, you shut up.
Okay.
That's the rule, right?
It's a hard rule, isn't it?
No, for him. it'd be the
Well, no,
worst.
Ty, you're slowing me down right away. Stop doing that. Okay,
Yeah, okay.
cosine. Ty, now you can talk. What is it?
Cosine, remember?
Ty. Adjacent over hypotenuse.
I don't know.
Okay, Elsa, what is it?
Adjacent over.
Yep, I got that. Adjacent.
-6 over 10.
Negative 6
Yeah,
over
negative
That's
6.
CAC.
Okay, negative 6/10. Reduce it to what?
Negative 3.
Okay,
I mean, over 5.
negative 3/5.
Yep.
Okay,
So
secant.
do the
Negative
opposite,
5 over
do you
3.
take away the negative?
What now?
no, so
No, I kept the negative.
When you do the secant.
Oh, but the opposite is positive, Jay, because we're going up. The x value is negative because you're going backwards. So sometimes your legs have negative values. It's because you're in quadrant 2. The x is negative, the y is positive.
You just keep it.
You keep it, yeah, you keep it. So secant will be this answer except what?
negative
Flipped. So flip it to get what?
Negative 5 over 3.
Okay? It's kind of nice. You just flip them and then you get the answer. Okay? Tangent is what over what? Give me words.
Radius over
opposite over
radius.
Opposite over what? Adjacent. But if you wanted to give me letters, you'd probably say y
over X.
over the x value. Well, if it's just y over x, God, look at this. Here's the y value, 8, over the x value, negative 6. So you're saying,
Negative 4.
whoa, I did that wrong. It'd be what?
Negative 4/3.
8 over negative 6, which reduces to negative 4/3. You're right. The cotangent answer would be what?
Negative 3/4.
Negative 3/4. Got it. Good? These were easy. Why were they easy? Because the numbers were integers. Are numbers always integers?
No.
No, sometimes numbers are irrational, like square root of 5 and square root of 7. They get messy. The next one's messy. Go. Do the next one. Now, I don't think that's the right number, is it?
It is. Or no, it's
I think
7
you guys have
over
7.
-2.
7 negative 2.
Okay, you guys have that. Okay. So go ahead, fill it in. Fill in the triangle with the number, okay? I didn't see a triangle, so I made a triangle. From the point, I went straight to the x-axis, back to the origin, back to the point, up, over, and back. Okay? Then I made the triangle with the right angle there. Do I know the legs?
You do not yet.
How far over did I go?
7.
7.
2, -2.
Down.
-2, yep. Okay, so now you know what? I just want to get rid of some of these numbers, so that's 7 and that -2 can go away. And there it is. The problem is, if you've already done it, the problem is the hypotenuse is not good.
Square root of 53.
Yeah, it ends up being the square root of 53 because you're going to do this. You get 49 plus 4, you'll get 53 equals hypotenuse squared. Right? Okay, you'll take the square root of both sides, and what does the hypotenuse equal? Square root of 53, and can you not reduce it, but can you simplify it?
I don't think so.
Is there a perfect square that goes into 53?
No.
4, no. 9, no. 16, no. 36, no. 25, no. Okay, so what's the distance from the origin to this point right here? What's that distance?
Square root of 53.
Square root of 53, okay. And this creates problems. Students don't like this problem. This is what happens on the test. They get this funny answer and they don't know what to do. So here we go. Sine is. If I talk about letters, it's 1 over what?
I don't know. I know it's opposite over.
I know, you know it's opposite, okay. Think about that unit circle. Y over R. That's all it is. It's the Y value over the R value. Well, which one's the Y value? 7 or -2? Yeah, of course it's -2. If you want to think opposite hypotenuse, Carlos, that's fine. It's -2 over what, guys?
Square root of 53.
Oh, 53.
Okay, now, that is the answer, but the problem is the answer, you can't have radicals on the bottom. It's like a big no-no in math. No radicals on the bottom.
Multiply by itself.
Okay, and J, if you took that times that, on the bottom, you get,
3.
and on the top, this times this, whoops, and negative, right? Okay, now, is this reduced?
Yep.
Look at the -2 53rds, is that reduced?
Yep.
Yeah, you're done. We might as well just get the reciprocal function, which would be what?
53.
No, what's the name?
CSC.
Cosecant. Cosecant of theta. Now you can do one of two things. You can flip your answer, and if you do flip your answer, guess what? The square root of 53 ends up where? Then you're going to have to do all that work again. Or you could go back to your original answer like this. That was your original. Flip that. What do you get?
53. Square root of 53 over -2.
Yeah. And by the way, the negative doesn't have to go on the bottom or top. It just needs to be there. So that's the answer.
Easy.
Yeah, it is. Don't flip this one, though. You flip that one, you got more work to do. Flip this one. Okay. Let's,
If you did the work for that one.
yeah, you'd get this, Jay, but why do you want to do that?
No.
Yeah, I don't either. Okay. Next up is cosine. Cole, do you know cosine?
Whose address is that?
Top left.
Yeah.
Oh, that is right.
What the heck?
Where did it come from?
Who's is that? Anybody know who said this?
It's Alyssa Nelson's.
Okay. Cosine. Cole.
Who says so?
Okay. To me, cosine is adjacent over hypotenuse. So you would have to say adjacent would be here, wouldn't it? Right here. 7 over the hypotenuse. Square root of 53. You okay with that? You okay with what I said there? Okay. Now, problem is you can't have square root of 53 on the bottom, so you got to do the whole thing over again. Ready? Square root of 53 times square root of 53, which will give me 53 on the bottom, 7 square root of 53 on the top. Is this reduced right here? 7 53rds?
Yep.
Yeah, that's done. cosine is this. Okay, now you want the reciprocal function, that would be what? Secant of theta. You either flip this
No.
or you flip the original answer, this answer. I'd flip that. Square root of 53 over what? 7. Good?
Yep.
Alright, you guys are probably gonna like tangent here because
It's easy.
It's
it's
easy.
very easy. Tangent is what?
Sine over
easy.
-2.
Okay, it's opposite that number over what? The adjacent 7. So I get a really nice number, a nice fraction, negative 2 sevenths. I'm done. Where cotangent would just be
7 over negative.
negative 7 halves. Yep, just flip it, and you're done. So there's cotangent, there's tangent, secant, cosine, cosecant, and way up there was sine. That was not as easy as the previous problem, but it's doable. Okay, keep going. This is where I ended up quitting in the last class. So where am I at now? Is this right?
Yes.
Is it?
Problem 2.
I'll go back.
We have a problem 2.
Okay, it must be here. Must be, yep, here it is.
Yep.
Okay, problem 2. Now you look at this triangle. This triangle is DEF. They want you to come up with all of this. Looking at this, guys, you have to look at the letter they're giving you. Angle D is right here. And they want what? Sine.
Yes.
Opposite over what? Hypotenuse. Which equals, there's a book assignment, just so you know. Okay. Opposite is what?
Opposite 5.
5. Yep. Over
5 is 13.
5/13 is good. You know what? I'd stay with D. Look, it's angle D. Let's go back. Let's go to angle D again. Now they want what?
CSC.
Cosecant. Do you know that cosecant is just the reciprocal of
Sin.
sine? So what would you put?
13 over 5.
Are there any more D's? Yeah, here's a D. Stay with D. Tangent, opposite over what?
Adjacent.
5 over
Adjacent.
12.
13 over. 5 over.
Opposite
5 over 12.
5 over 12.
over, yes, 12.
My money.
Adjacent. Okay. Now guys, I'd do all the D's and then I'd go after all the F's. That's what I would do. Because you know, opposite and adjacent will change that. Now do F's.
Look out, Jason over opposite. Jason over opposite.
F is here, opposite, adjacent. Hypotenuse. Okay. Oh, let's do the easiest of all. I think the easiest of all of them is cosine of F. Cosine's easy because it's the main one. Adjacent over what? Hypotenuse.
5 over 13.
Jay says 5/13. What do you guys think?
You correct?
Smart.
Okay. Now, if cosine of F is 5/13, is this or this reciprocal of cosine?
E is.
Which one is?
E.
Like letter
Actually, secant is the reciprocal of this. So this would just be what? 13
That's tangent.
fifths. Okay. This one is cotangent, the reciprocal of tangent. Now, if tangent's opposite over adjacent, this would be adjacent over opposite. So you tell me, what? 5/12? Yes. Okay, there you go. Good?
Yep.
Yeah, okay. Next, down here, they give you, it says finding trig ratios. In this triangle over there, angle D is a right angle, so that's right here. Okay, and tangent of E is what? What's tangent of E?
Opposite over
3
hype.
fourths. Say it again.
Opposite over hype.
Okay, so then, does that tell you anything about where to put the 3? Where to put the 4?
You just flip them.
Angle E, right here, here's angle E. Where's the 3 go?
The 3 goes
Opposite of angle E, so that would be here,
right
wouldn't it?
there.
Okay, where's the hypotenuse? 4. That'd be here. You got a problem. What's that side? You think it's 5?
You got to do the Pythagorean theorem.
X.
I did something wrong and you guys didn't catch me.
It's not
Tangent
opposite,
is
it's not-
opposite
or adjacent.
over adjacent. You guys didn't catch
That
me.
was my fault.
Okay,
Why would you do that?
so now the 4 goes where, guys? Where does 4 go?
Between D and E.
Okay, between D and E, it's here. Now you do Pythagorean theorem, correct? And you get 3 squared, 9, plus 4 squared, 16, equals hypotenuse squared, 25, so it's 5. Okay. Now here comes the question. Find each value of the as a fraction and decimal, rounded nearest hundredths. Oh, what am I looking for? Sine of E and secant of F.
Opposite.
What is sine of E?
Opposite over
Opposite over hypotenuse. Where's E? Right here. There's E. Opposite over what? Hypotenuse. What's the answer?
3/5.
3/5. As a decimal, 0.6. Next, secant of F. Secant of F equals.
Opposite of
5 almost.
This is the reciprocal of who?
cos.
Cosine. Hypotenuse over adjacent, right? Which is what?
5/4.
F is right here.
3.
It'd be 5 over, yeah, it's 5/3. Okay.
Book assignment?
Hey, in your book assignment, there are a couple problems you can't do. It's the ones where they say, find the missing side of the triangle. You can't do it because I didn't get to the next slide. So this is 1.6 degrees. Okay, that's it.
I have an assignment calendar.
Can you have one?
Yeah.
Yeah. Did you get it? No?
I got it.
Yesterday, the worst today. A couple problems you can't do.
Yeah.
Is that the one?
No, it's the 11. Give you one more.
Yeah. Okay, Nakia, you stayed quite a while.
I was doing the packet from 11.6. Trying to study.
11.6. Is that what you said?
Yeah.
What 11.6? Oh, section? You mean you were doing the book assignment?
No, the notes. I didn't do all the notes. I was trying to do it on my own.
Oh. Okay. Wait. Where's your quiz that you took? Where's your quiz that you took?
This the quiz?
That was the quiz the whole time.
I did not know it was up here.
Where did you go?
Didn't I take that quiz?
No. This is the one you just told me you wanted to take. Right?
Yeah.
So the whole time you weren't taking the quiz? You were just working on an assignment? Okay, let's just make sure you have to take that quiz before you take the quiz, okay? Hmm?
Do you have a homework quiz? Oh, God.
Well, that's, yeah, we did have a lot of homework quiz a long time ago, but hang on. Let me take a look. What you, make sure, I don't want you to take that quiz if you already took it.
I haven't taken it. Comes out.
I have Nikia with a blank. Blank right here. You took the other quiz right here. Did not, you have not given me 1, 2, 3, 4, 5, 6, 7, 8. You haven't given me 8 assignments.
You know,
You do know that?
we were talking about it. Resource.
Okay. And what are they saying?
They won't be doing all. I'm working.
Okay, but okay. Yeah, this is my thought. My thought is if you don't do this stuff, trigonometry, you're gonna get even more lost.
I get this, like, it's not,
Oh, okay.
it's not hard.
But what I'm saying to you is, if you don't do this, you sit there and you do all that stuff again, you'll be doing that, and you won't be thinking this, and then this will get you messed up because you're over here, I'm over here. You're on one island doing statistics, and I'm on another island doing trigonometry. It doesn't work. So where do you do this homework? Probably at home. You know, in school you need to concentrate on that stuff, trigonometry. You can ask for help on this. I think go home at night and do it by yourself. You're gonna get yourself in trouble doing too much of this and not enough of that. You're already in trouble because look. The grades kind of say that. So my thought is, okay, you know you didn't do well here. Okay, now let's do well there. You can get more points. You can get some points, but I don't think you're going to do that well because you haven't done enough homework. But just go ahead and get the points that you can get, homework-wise. Get as much as you can, do it at night. Okay? Now, let's say we salvage this grade and we get it from, it's not a good percent, maybe we can get it up higher, and then trigonometry, you get better, and you get that low score to come up to here. You know what I'm saying? But don't ignore this stuff, because you're gonna get caught working on this and not working on that. Alright, long enough speech, sorry about that. Are you gonna do this?
Take it home or?
No. I suppose you have class now. Yeah. Yeah, what? Oh, you better go. Go to art.
This there, this.
Who's your teacher?
My art teacher, Shaw.
Child. Okay.
Is this right? That's.
Standard deviation. This is right. I'm not supposed to tell you.
That you're supposed to tell me.
That I am.
Oh,
Um,
well, I already did all the work. I was just.
you added all this, right? Did you divide?
Yep.
By 1, 2, 3, 4, 5, 10?
That's what I did right there.
Oh, right here. Gotcha. And then I gave you
Square
this. Okay. And then you got this?
Yeah.
Did you read that? English 10? Is that right? 28.8? Okay. I actually thought it was.
So I should go to 29.
No, nearest 10th. It's either 0.8 or 0.9. I guess I thought it was 0.9, to be honest. It doesn't matter that much, you know.
What was it? 80.
Square root of 833, you wrote 0.1.
28.86.
So it's 8.6, so that'd be 8.8 or 0.9? Yeah, so that's okay.
Then all my other answers are gonna be wrong.
Yeah, but I knew that that would be a tiny bit off. That means that every answer is a tiny bit off. I wasn't marking you guys wrong for that. Where I really marked you wrong is if you maybe it really depends on how these answers look after you got that answer. That shouldn't matter much. Like you should be just off a hair. If you're off by more than a hair, like a lot of hairs, then I gotta take points.
can I get a note or?
Yeah, now where are you supposed to be?
I was in resource and then now I'm going to marketing.
Okay. Are you done?
Yeah.
Okay. How's your St. Cloud trip?
I think I did really good on my first case problem, and my second one was like, it was doing a business model. I've only been in marketing for a week and a half.
Oh. Week and a half, and they took you to St. Cloud?
Yeah.
Oh. Vision quiz and.
Yeah.
How about, did you run into any snow or?
We didn't go to Albertville because there was snow coming, but like once we got to St. Cloud, it just like started snowing. They
Oh,
we got
really?
like a couple inches, 2, 3.
Well, they did. It wasn't bad then.
So we were just driving through the town when it was snowing, so we weren't like on the highway.
Oh, so you just had a nice highway all the way there?
Yeah. Like 20, 30 minutes out of St. Cloud, we got a little snow, but
Coming back, was it
coming
good?
back, it was nice. It was really warm.
Coming back, the roads were good?
Um,
Oh, I thought I heard Fargo got snow yesterday, that's why I was asking you.
They were, by the time we left at like 3 or 2.
Oh. Yesterday.
Yeah.
Left at 3, home by 7?
I think I was home by, 5:36. Actually, we left at, I don't know what time we left. We left at like 1-ish or something.
So, yeah.
Did you say you were calling a meeting for
Yeah.
It looks so nice.
It does look nice?
Kinda cool.
17 when we came here.
Yeah.
They said it wasn't gonna warm up though.
Did that not have that before? So I just looked.
You what?
You put me in as a 0. So you know
For what?
I had 3.8,
3.8, well.
which was yesterday's.
Was it?
Yes.
I don't think it was. Because this was yesterday. Pretty sure. Yeah, this was yesterday, and Brandon has it marked as a 3.9, but that doesn't mean it's right. It could be.
So I looked and I don't have it in my.
Okay. So 2, oh, because I have it over here. Okay, so we're talking about. Yeah, you gotta go back to. Yeah, this was today, this was yesterday.
So
Now I'm
Tuesday?
now I'm going back even further. So
Tuesdays?
this was handed in today. This was handed in Wednesday. This was handed in Tuesday. So it says, let's see. Transformations 1 through 6. So there were 6 problems to do. It was actually Monday's assignment. Were you here Monday?
Yes.
Okay. Monday, that's Monday. It's the one where we had 6, just 6. There, here. So there's Noah. Okay. David.
Yeah.
What?
You have mine.
There's 6. 2.5. Missed you. And that's it. I'm just gonna make sure cogs down. Cogs down at 2.5. Yep. I missed you. What'd you have?
2.5.
Just, 2.5, and then go back to trouble. Kingsley, okay. Klein got 2.5. Yep, okay, so I missed you.
Okay.
I just missed you.
Alright, that's okay.
Yep. and 5. What's going on now?